Hey guys, welcome back. We've got a bunch of definitions to go through today. But before we get there, I got a question for you. Why was the belt sent to jail? For holding up a pair of pants. You know you laughed a little on that one. All right, so when we have a line that intersects two or more lines at different points in a plane, it's called a transversal. So in this particular situation here, I got my two black lines here and this green guy running through. That's our transversal. It turns out that 8 angles are formed when you have a transversal cutting through two lines. So I've numbered them here. 1, 2, 3, 4, 5, 6, 7, 8. And these angles, the relationship between some of these angles has a certain name. And so we're going to define those for you today. So let's take a look here, and like I said, we'll try to show you on the picture and define these interior angles. When you think of the word interior, interior means inside. So interior angles are the angles that are inside the two lines, right? So we're talking about 3, 4, 5, and 6. They are inside. Think if you were to squish the two lines together, who would be squished inside them? Those are interior angles. So again, angles 3, 4, 5, and 6 are all interior angles here. Let's see, I think I'm going to put those down here so that they don't confuse you. Angle 3, angle 4, angle 5, angle 6. That way we're not messing up our picture over here. All right? So interior angles inside. So we've got a couple of special kinds of interior angles. The first one is alternate interior angles. If you think about alternating, alternate is like every other one, right? So not in a row, but every other one. Our alternate interior angles are inside the two lines, but on opposite sides of the transversal, right? So 3 and 6 would be alternate interior angles, right? Not in a row, but skipping, alternate interior angles. And then of course, 5 and 4 would also be alternate interior angles. Okay? So we're going to write here angle 3 and angle 6 are alternate interior angles. And then angle 4 and angle 5 are alternate interior angles. Right? Okay, I'm going to erase those so that we can use these angles and talk about a different kind of relationship. Consecutive interior angles. Again, the word consecutive meaning in a row, the next one. And so when we talk about consecutive interior angles, an example of those would be like 3 and 5. Consecutive interior angles are inside the two lines, but on the same side of the transversal. Right? Inside, same side. So 3 and 5, that would be an example of consecutive interior angles. And you can probably guess the other set, in this case 4 and 6. They are also consecutive interior angles. So angle 4 and angle 6. Consecutive interior angles. All right? The next type of angle we're talking about are exterior angles. You can probably guess what that means. Exterior means outside. If you use exterior paint, you're painting the outside of your house. And so exterior angles are going to be outside of the two lines. Again, inside gets smashed, outside, top and bottom. Okay? So in this case, we are looking at angles 1, 2, 7, and 8. Outside the two lines. Okay, so angle 1, angle 2, angle 7, angle 8. These are all exterior angles. And similar then to alternate interior angles. Remember, the alternate interior angles are on opposite sides of the transversal. Same thing applies for alternate exterior angles. Different sides of the transversal. We're talking about 1 and 8. Again, different sides of the transversal outside the two lines. So alternate exterior angles would be like angle 1 and angle 8. And the other set, you can probably guess, angle 2, angle 7. Angle 2 and angle 7. So again, kind of defining the angles for you. A few different kinds of angles, again, having certain relationships, and the names of those, hopefully some examples there will help. You're going to use some relationships between these angles to solve some problems. So I'm going to show you an example problem of how we might use this idea of alternate interior, consecutive interior, alternate exterior angles to solve some problems. Okay, so let's look at an example. Now, something that you need to know is that if the two lines that the transversal is cutting through, if those two lines are parallel, then there's some special things that happen. In this case, if the lines are parallel, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles add up to 180. So what that means is, let's take a look here. Here would be an example of a transversal cutting through two parallel lines. And what we just said is that these two angles, alternate interior angles, are congruent. These two angles here would also be congruent to each other. And we know from a previous lesson that vertical angles are equal, and so we know that that angle equals this angle. That's cool. And by the same idea of vertical angles, we would know that this blue one is equal to that guy right there, and this blue one is equal to that guy right there. And we have just shown then that alternate exterior angles, like this guy and this guy, that they are congruent. And it turns out that consecutive interior angles, that means this green guy here and this blue guy here, have to add up to 180. So this is kind of your key to doing problems like this. All these blue angles, you see this kind of zigzag here, they're all equal. All these green angles are equal, and any blue and green together would add up to 180. So we're going to use that idea to solve some problems. So I have a picture here. This looks a little bit complicated, but really it's just two parallel lines and a line cutting through it, a transversal. It just so happens that I have two transversals, so I'm kind of doing two problems in one. And the goal here is we want to solve for all of these angles, and we have a little bit of information that we've been given. So let's go do some easy stuff first. Remember that vertical angles are equal. Remember, vertical angles are formed when two lines cross. They're the two opposite angles, vertical angles, right? And vertical angles, the measures of vertical angles are equal. And so this angle 4 right here, that's just 80. Same thing here, angle 5, super easy to get. That guy, just 60, vertical angles, right? And we've previously looked at problems having to do with supplementary angles or straight lines. I got a whole bunch of straight lines here, right? I got this straight line here. So this angle, angle 4 and angle 7, that's a straight line. They have to add up to 180 degrees. So if this guy's 80, what plus 80 would be 180, 100. So this guy, 100. And then vertical angles, 7 and 10, vertical angles. So this guy is also 100. You do the same thing over here. Again, I have a straight line right here. These two angles together have to add up to 180. What plus 60 is 180, 120. And then same deal here. I got some vertical angles. Angle 9, also 120. So actually, to find all of these angles down here, I didn't even have to use any of this new stuff really. All I had to do was use some old stuff, vertical angles, straight lines, supplementary angles. These are going to come in handy though a little bit to help me jump up to this next line, right? Because these help me relate stuff down here on one line to stuff up here on the other line, right? And so now I just need to go and find maybe some alternate interior angles, alternate exterior, and again, sometimes this gets a little crowded with two, and so what you have to do is just pretend that one of them isn't there, right? So I'm going to take this, and I'm going to just talk about this guy for a minute. This is my transversal. These are my two parallel lines. And right now, I am going to pretend like that black line is not even there, right? And so I'm going to go see what I can find out just looking at two parallel lines with a green line cutting through. Basically this picture right here. So I'd like to get up and know something about one of those angles. And again, I'm going to pretend. In fact, to help you pretend a little bit better, this is easy for me to do. I am just going to erase that black line for a moment. We'll get it back there in a minute. But now you can see that picture a little bit better. If you'll notice, angle 5 and angle 1 are inside the red lines, but on opposite sides of the transversal. We have defined that to be alternate interior angles. And when these two lines are parallel, alternate interior angles are congruent. That means 5 and 1 are the same. Now, I could also do a little thing with some alternate exterior angles. You know that this red line and this red line, the angles that are outside are exterior angles. That means 8 is an exterior angle, and these guys down here are exterior angles, and 8 and this 60 right here are alternate exterior angles, which means they are equal. So I can use alternate exterior angles to determine that 8 is also 60, but there was actually even an easier way. Remember all that vertical angle stuff we were doing down here? Turns out angle 1 and angle 8 are vertical angles, so they have to be equal. So once I find 1, I've got 8 right there. Now, 2 and 3 are a little bit trickier. Remember, there's actually 2 angles there. I erased the transversal that went through there, but let me draw it back. Right? 2 and 3 together plus 60 would have to equal 180, straight line, the red line. But I don't know either one of them. So I need to figure out something about angle 2 or angle 3. And so, again, to help you see this a little bit better, I'm going to completely ignore the green line, and because I can erase it fairly easily, I'm going to do that so that you can visualize that a little bit better. And if you'll notice there, when I erase that line, angle 2 is just kind of out in no man's land. That's not really an angle. Angle 1 and 2 together would be this big angle. I don't really have an angle there for 2. It's 3 that maybe I can figure out. And so if this is my transversal and these are my parallel lines, I know angle 3 and these guys down here, those are interior angles. If you'll notice, 4 and 3 are on opposite sides of the transversal, so they are going to be alternate interior angles. And alternate interior angles are equal. We've only got one angle left, that's angle 2. I'm going to bring back this green line. It turns out angle 2 is this kind of triangular piece in here. We mentioned this a little bit earlier, maybe you remember, but if I look at this red line here, angle 1 and angle 2 and angle 3 all together add up to 180. So if I add 60 and 80 together, and then subtract that from 180, I'll have 2, angle 2. Another way to look at it is 80 plus 60 plus what is 180. So again, I'm just going to take the route. I know that this whole thing has to be 180, so 180 minus 80 is 100, minus 60 more would leave 40. Angle 2 is 40. And now I've successfully found all the angles using some vertical angle stuff, using some straight line 180 degree stuff, and then using a little alternate interior, alternate exterior. We didn't really use any consecutive interior angles, but we could have. We could have used that to find number 3 also. We knew this 7 was 100, and 7 and 3 are consecutive interior angles, and they have to add up to 180, and sure enough 100 plus 80 is 180, so we could have used that as well. Anyways, you've got lots of tools to be able to figure out these angles. Now it's up to you to decide which tool to use and solve them. You're going to have a problem similar to this where you have a whole bunch of angles that you're going to be looking for. So use all your tools. Remember, you've got more tools than just these. You've got your vertical angles, you've got your straight line stuff, equals 180. Go to work.